In this video, I'll be covering how HAX the Web is literally hacking the way web development and web applications are built, deployed, maintained, and sustained over the lifecycle and beyond. In order to do this, we need to look at where the web was for a very long time. Now, I don't mean the early 90s, I don't even mean the early 2000s, but the web that we have today is largely born out of technologies established around early 2000s as a result of what was going on the internet. At that time, we had Apache. Now we could swap that out for Nginx, MySQL, a database system, and PHP, or personal homepage based language, to process and power the web. This formed into solutions which are now 20 plus years old, with Drupal, WordPress being two of the bigger ones. In both of these instances, these systems can support standalone copies or what is commonly referred to as multi-site, or the ability to spawn new websites rapidly. Every page you access is going to read or write to the database in some form. As a result of this, we're trying to basically just generate HTML, CSS, and JavaScript. These content management systems were a way that we could scale the user's inputting material, limit the options with intentionality so that we could render websites and web properties that we want, even if they're developed by lots of people that have varying technical abilities. Somewhere along the way, though, it went from very simple sites that looked acceptable into beautiful, branded, enhanced applications, web apps, top level domains and properties. We could no longer just rely on traditional HTML, CSS, and JavaScript to deliver these. In comes design libraries, things like Bootstrap, Material UI, Material, Tailwind, and homegrown systems that are patterning ideas from these design libraries. Then, however, came JavaScript frameworks and libraries, things like Angular, Vue, React. And by coupling the two of these together, you could get React-based blocks, little building blocks and components that give us brand standardization made in the material design framework, implemented in our content management system, which ultimately is just outputting all of these. However, in order to actually scale that out for people in the end, we have a class of technology known as static site generators. And while we're not directly saying that Drupal and WordPress write to these formats, they do end up starting to behave a lot like what these have started to achieve. Static site generators got very popular in the last 10 years, especially so in the last 5 years. And the idea is, using a build routine or continuous integration methodology, some robot magic behind the scenes takes the code, generates it in a static format that is easy to deploy on applications such as Netlify or Vercel. Something that is static, doesn't need to have the same security considerations and scalability considerations of a traditional database-driven solution. Instead of every page being reads and writes, every page is a reverse proxy setup hitting a static file. The JavaScript or HTML that you see isn't coming from a database anymore. It's coming from a file interpreted from all of what you see. And this was great for a long time. The issue, though, is that the complexity of this stack quickly went from understanding this portion to having content management systems abstracted into needing to be an expert in every one of these things just to obtain static output again. Now, part of this was so that we could have multi-user authoring. There's lots of incredible work in both of these communities, and I don't mean to demean them in any way by saying this. However, the stack has gotten too complicated for the average web developer or just normal person that wants to present themselves online. Let's fast forward to a different way. This is HAX. HAX is what I've coined as a hybrid static site generator. It's using the idea of static site generation technology, but without the command line interfaces. Why? We can't empower the next billion creators online by telling them to run commands in a terminal window. We can't empower the next billion creators by telling them to download a content management system, set up their own version of Apache, PHP, run scripts, lots of technical overhead just to put themselves online. And the market has reacted to this. We have things like Wix, Squarespace, Weebly, Website Tonight software is all over the place. It's very easy to spin something up for $10 or $20 a month and never be able to migrate. So, how is HAX different in this way? HAX takes inspiration from static site generators. Everything produced in HAX works in or out of HAX. It works anywhere. It can support multiple backends because HAX is short for headless authoring experience, implying that the front end and back end of the solution are two separate types of systems. The most common version of HAX, as seen in the wild, is called HAX CMS. This is a PHP based system that runs on Apache. However, we have prototypes that demonstrate this on Nginx. We also have prototypes that demonstrate this as a fully offline capable desktop application, as well as a HAX.cloud website that turns your file system with no installation into the quote unquote backend to power a website. And yes, we do support and are able to work on top of systems like WordPress and Drupal. HAX, or in the case of HAX CMS, supports multiple sites or a singular instance alone, just like its predecessors. However, unlike before, where all reads and writes are to a database, every operation in HAX, of which there's really only about 5 or 6 that are doing writes and need a quote unquote backend, are just orchestrating and writing to the same static files that in our old system would be output down here. We're skipping a huge part of the tech stack in order to participate in the web, but we're not doing so in an exclusive manner. This is possible because of a new standard that emerged around 2019 known as Web Components. Web Components was started as an idea in 2011 by Google primarily, matured slowly over a decade, and finally has reached maturation 2019. For the last 5+ years, our team has been investing in web components, seeing that they were once on the horizon and now the norm. You experience web components everywhere you go on the web, whether or not you realize it. Whether it's Wordle or YouTube or Comcast or a popular gaming website, they're everywhere. In fact, if you're viewing this video on YouTube in the Mozilla Firefox browser, the browser itself is written in web components. Web components are a level below traditional frameworks and libraries. In this regard, they work with projects we have, such as React, Vue, Angular, but they also work in all of our content management solutions that currently exist. If we style those web components in order to look like a certain design library, whether it's our own homegrown one, Tailwind, Material, etc., they're going to look that way, no matter the framework they're placed within, and no matter the content management system that they ride within. Ultimately, web components are just made out of HTML, CSS, and JavaScript. They are a meta specification, meaning a standard that when these 4 parts of a specification are implemented, form a new type of HTML. Web components actually are HTML. They're just custom HTML that works everywhere, so long as the definition is available. These things naturally fit into being able to be scaled very high on very low resources, and everything in HAX is written and powered by web components. So we still play nice with our static site generators, but we don't have all of the tool chain involved to get stuff there. Everything output on every save of HAX is by default high performance and in a pervasive format that works forever in any system. If that sounds bold, here's how this is possible. HAX ultimately boils down to a tag, a web component HTML tag. Imagine you have div and bold and other tags making up every page you've looked at on the internet. However, HAX H-A-X is written in all of those same web standards. And by getting the definition of the tag onto any page, all of the functionality works the same no matter where it is. What makes HAX special in the ecosystem of web components on the web more broadly is that HAX uses a schema surfaced by other web components to allow for a user experience where people write HTML without knowing it. For example, a video player tag is a very complicated thing. However, once we've solved that problem once and we put the definition either on a content delivery network or we publish it for other developers to use, we can replicate that exact same design pattern without any overhead as far as how do we go about integrating this. We're just getting the definition fed to the page, and then we're thinking about the semantic use case, in this case, a video player. If we want to style it to be an accessible color contrast ratio, we change one property in that tag, and all the internals of that tag guarantee that that remains accessible no matter the background color. So our users using HAX-based systems are writing highly semantic web components without realizing it. We're giving them authoring experiences, also written in highly semantic web components, so that our team can continue to work forward, be invigorated with a modern web technology, and build amazing stuff by building amazing stuff previously. These things work forever in every system they will ever touch, and they work together. So the video player in this case has a very lightweight schema that if HAX is there, will build the interface for it, editing, when it's clicked on. Ultimately, the user sees the video player in the page and they get the visual confirmation of what they're changing. However, they're always unknowingly writing HTML. On save of the page, we simply take that HTML and save it in a flat HTML file. As a result, building at what we're commonly referring to as infinite scalability and capability as developers, we're able to focus on ethical pillars of development as opposed to the nuts and bolts, div tags, A tags for linking. How are we going to scale and hit performance targets? We don't think in those terms anymore because we've done them at the very small bricks. We're pointing to two tags in this video. As of this time that this is recorded, there's north of 1,000 of these tags. These just happen to be two of the more impressive ones. Our pillars as a community with HAX the Web involve accessibility, that everything seeks to be the highest level of accessibility by design, and also by being pegged to a highly semantic term system as far as video player, or if we have a button, that it is a simple button, things like that. This allows us to point to singular files in the event that we do have an accessibility issue that goes unchecked, so that people are no longer redeploying the fix for accessibility. We're fixing it in one place, we're pushing out to a content delivery network, and then the problem is solved, no matter how many times that tag is used. Another pillar of our community is that we're platform agnostic. While code can be written in HAX to work with specific platforms, and at times is, the core of the platform needs to work everywhere by design. That is the power of the solution. It also needs to be free and open. The system is open. Everything it outputs can be remixed easily. And between these two capabilities, we have an OER, or Open Educational Resources, powerhouse. It's extensible. People can take the system, build their own elements, deploy it somewhere else, start in one location, download and move to another. And because of this, they can use it in non-OER environments, whether that's for courses, whether that's student portfolios, whether that's top-level web properties. Or another focus we have is on sustainability. It's one thing to say that we care about the environment, and it's another to build in a sustainable manner that ensures servers never turn on. Web development and server technology that's running 24 hours a day is eating up a carbon footprint that we have no control over unless we attack the web differently. By shipping very small web standard code to end users, repurposing that code on cross content delivery networks, we're actually able to send no bytes after people get the initial content. Because of the way that we're developing and all of these little tiny pieces that unpack, you only get the code that you need for the website you're on. However, the next website you go to that's also using these pieces, you don't get hits for any of that material. In my own teaching with this software, all of the compliments that I initially got to realize this was a focal point of ours came in 2020 when the pandemic hit. I had students on the other side of the globe having to access web resources and calling in at 3 a.m. their local time to tell me that my web platform loads instantaneously while other resources coming from traditional learning management systems were unusable. That hits at performance as well. If something is accessibly generated, but it's not performant, it's not accessible. 15 minutes from the university where this has been produced, if you cannot download things faster than 56K, as is the case in rural and inner city America, let alone other countries, it's not accessible. So we obsess over performance. Every piece of code needs to be the minimum amount of code written and shipped, not just in the build routine that we're looking at right now, but in any web property anywhere. Now, I love a good diagram. However, in practice, when I've written the video player, that gets published to NPM. This means other developers can take the video player. However, through these two lines of code, you can access any element in a highly performant manner on the Penn State Content Delivery Network dedicated to web components. Using this guide, you can see the video player. I can look at it from a design perspective. And this is a tool called Storybook. So normal users that are experiencing websites would not use something like this. However, it's a great way of communicating the vision of the branding of what we're working on. Copying this video player will give me the identical output to what I'm seeing here, no matter where it's implemented. Whether that's on hackstheweb.org, if I were to right click and we see a video player, that will work that way every time, no matter where it's used. Or if that script is added to sites.psj.edu, a WordPress-based solution. In this case, we see the video player loading on a WordPress-based system. There are no WordPress-specific plugins to make this video player work. Or in our online courses, where most of this work has come from. In this case, we have Music 109, Beatles course, which is actually running on top of a Drupal-based system. So while this is HAX and the editing experience and the video player, we're on top of a traditional content management system solution. Or in this case, the video player running on something that's published with Eleventy, a static site generator. In this case, there is no traditional backend. The files are markdown. The web component code is copy and pasted from storybooks into individual quote unquote pages and pushed up to a repository. A robot goes and builds this website on every code push. And there are lots of courses across multiple colleges using and repurposing this technology. Again, not just for the video player. All of the cards on this page are available and work on every website anywhere. It could be things like communicating learning objectives. It could be the button that navigates between the website. It could be this printing and talking to a microservice that turns this current page into a PDF. It could be a QR code. Literally every aspect of development can be encapsulated in web components and transform the web as we know it. Wiring that up to HAX, then, we empower other people, non-technical people, to remake the web as they see fit. As another example of remaking this web, this is a previous little course space that I made, downloaded as a static zip file, and then uploaded into Canvas LMS. This output is working standalone without hax.psu.edu where it was originally produced. But it also doesn't matter where it was produced, whether it was on hax.psu.edu or started on a local desktop or started on hax.cloud. Because we're backend agnostic and we're always writing to static in this hybrid static site generation technology, the outputs are always ultra fast, work everywhere, and highly scalable. Even if that's in a code pen. In this case, I've got video player, I've got a multiple choice question on the page, I've got confetti and interactivity, I've got an astronaut and a 3D model in place, I've got Spotify, I've got code examples. The possibilities are endless with this methodology. The entire hax.psu.edu website is made of web components. Students in IST curriculum learn how to create web components because it simplifies the production process of the web so that we can have fun building websites and web properties instead of focusing on the nitty-gritty. Everything here is thousands of web components working in collaboration, talking to very tiny backend code in order to edit static files that will reload instantly. Every aspect of the HAX authoring system, whether it's editing in place, whether it's calling up from our huge array of blocks that we support and putting in learning components, self-checks, notes to stop, timelines, worksheet downloads, multiple choice questions, whether we're laying out material in a card or in block quote, no matter what it is, if we're viewing information in tag form, if we're embedding from X or Twitter, if we're putting a course model in the page, no matter what it is a web component that is sustainable and works forever. Everything that is produced is ultimately writing to HTML. And so I can go to Fun for Once, I can view the Git code on the back end, or I can just download this site. And what I just downloaded is the housing that makes up HAX CMS in this case, but my quote unquote database has constantly been statically written to a very simple JSON file. Every time a new page was added via clicking in the UI, it's just adding this little tiny bit of JSON that has the title of the page, what it should say in the address, and then the location on the file system. Speaking of file system, those pages and the page content is all right here. There's the first page in that HAX course in static HTML that works anywhere. The components on that page need their definitions loaded. And when those definitions load, no matter where that is, they're going to work. There's our video player in context. If I wanted to take the video player, open this up, select media, perhaps search YouTube, and find information about HAX the Web, I can replace that video. I haven't left the experience because once we've been able to work at such a small level and build out, we're no longer worrying about UI considerations like this button or the icon, or is that color accessible? Because we've not just thought through the problem, we've thought through the problem and implemented it in such a way that it's solved forever. And save and build anything with this technology. We've started with online courses. We're starting to get into websites. This is infinite scale, and it will continue to grow as more and more people understand this message. If you'd like to join us, go to hax.psu.edu, try it today if you're part of Penn State, and if not, read how you can download HAX and start playing with it yourself. Thank you.